Hello everyone, so today we're going through chapter 2, but the part where it's like modeling with quadratics. So let me first explain what is a mathematical model. So when we have a real life situation, sometimes we use maths to model that. And in this case, we're using a quadratic equation. That's hence why it says modeling with quadratics. So let me read through example 13 so you get a sense of what I mean. So a spear is thrown over level ground from the top of a tower. The height in meters of the spear above the ground after seconds is modeled by the function ht equal 12.25 plus 14.7t minus 4.9t squared. So you can see here that height is our variable, what we normally call y, and t is like the time is like what we normally would refer to as x, right? And we have a condition that's bound by it, which is that the time has to be positive, and that's real in real life. That's true, okay? So we can't take any negative values for t. So let me like draw maybe like a small representation of how this might look like. So let's say this is my tower. It looks a bit weird, but anyways, we don't care. So this is my tower. Yeah. Let's say this is a tower. And we've got a spear. So a spear is like a wooden kind of weapon with like a pointed tip that's like normally made of metal. So it's like, let's say it's something like this, okay? And this is the level, ground level, okay? So the height of the spear over time is modeled by this equation. So for example, at time 0 is on top of the tower. At some time it will be on the ground because we're throwing it, okay? So the the path is gonna follow, it will be something like this. Hence why we modeled it like with a quadratic equation. So it's gonna go like this and reach like a height, a certain height, and because you know the coefficient that related to the squared term is negative, and we said from like the previous sessions, when we have a negative coefficient, the graph have a maximum and it looks like this for a quadratic equation. When it's positive, okay, in the other hand, so when it's negative, the graph looks like this. When it's positive, think of it as a smile, the graph looks like this. So I'm just trying to give you an idea how this relates to the words that's in the problem, because part of it will help you understand and answer the questions, the following questions. Without basic common sense, you wouldn't be able to relate things together. Anyways, so let's interpret the meaning of the constant term 12.25 in the model. So what does it mean? What does it represent? So if we look at our model, 12.25 is a height only when t is equal to 0. So let's note that down. When t is equal to 0, so that means at time 0, okay, height is equal to 12.25 meters. At time 0, where is the spear positioned? Is at the top of the tower. So we just started the experiment, is at the top of the tower. So we know that the height of the spear is the height that is represented from above the ground. So above the ground, the height of the spear at time 0 is something like this. Okay, so this is h0. What does that represent as well is it represents the height of the tower. So the meaning of this constant term is like, so the height of the tower is 12.25. So this is like the useful piece of information we've gotten out of this constant, if that makes sense. So moving on to question B. After how many seconds does the sphere hit the ground? So we know that the height that we have represented is the height of the sphere to the ground. So if it hits the ground, then like gonna be like 0, okay? So we need to know the time, when does it hit the ground. So we set our equation to ht equal to 0, and then we have to solve it. And we've solved so many quadratic equations before, so I think most of you are comfortable with doing it, but regardless, we'll do it together. So our quadratic equation is as follows. We're going to use the quadratic formula. Okay. So the quadratic formula says, so in this case, our variable is t instead of x. So t is equal to minus b. Okay. So b is this one that's related to t. So minus b, so minus 14.7 plus or minus square root b squared, which is 14.7 squared, minus 4 times AC. A is minus 4.9 and C is 12.25. So that's times. The order here is a bit like the other way around, because normally we have t squared, t, and then the constant c. But it doesn't matter, you know. If you're more comfortable flipping it, it's fine. Then over to a. So a again is minus 4.9. And this is the quadratic formula. Using like a calculator, whatever that's inside the bracket will become plus or minus will become 456.19 over minus 9.8. So we've got two values here. We have t minus 0.79 when we do minus, when we plus, and when we do minus, or t equal to 3.68. Okay, so note this condition here that we talked before. Time can only be positive because time takes positive values. In this context of this problem, we will only use this value, hence why, well, let's say as t is more equal to 0, t is 3.68 seconds. So the spear hit the ground after, you can say, the spear hits the ground after 3.68 seconds. Okay, so now we're done with question B. Let's move on to part C. We're still in the same question. So write ht in the form of a minus b, c minus c squared, where a, b, and c are constant to be found. So here basically they're asking us to complete the square. Let me copy quickly ht from the previous slides. I think as ht is equal to 12.25 plus 14.7t minus 4.9 t squared. So this is ht for me. So I'd like to, you know, put it in the traditional kind of order so everyone can see what we're doing here. So 14.7t plus 12.25. So now what we'll do next is we're going to factorize by minus 4.9. The reason why we do this is because it will help us complete the square. So when we factorize, 14.7 over minus 4.9 is minus 3, that's fine. And we'll leave 12.25 alone, so we won't touch that one. So minus 4.9, and then when we complete the square, t minus 3 over 2 squared minus 3 over 2 squared. So I've only used this rule over here, equal x plus b over 2 squared minus b over 2 squared. In my case, minus 3 is the b. That makes sense. Plus 12.25. So now I'm going to expand to these two, okay? Minus 4.9t minus 3 over 2 squared. Okay? And all is left now is just to compute. So minus 4.9 times 9 over 4 minus 9 over 4, because anyways, minus times minus is going to be plus. So 9 over 4 plus 12.25. And computing all of that, I think this one will give us 11.025 Then if we add these two together, okay, 11.025 plus 1225 is going to be 23.275 minus 4.9 t minus 3 over 2 squared. And the reason why I flipped the order is because they asked us to write in this form, and I have to evaluate what A and B and C. So I've only written it that way so you guys can see. A in this case is 23.275. B is 4.9. Not minus, because minus is already here, so just 4.9. And C is equal to 3 over 2, 1.5, as you wish. And now we've got to use our answer to part E, or more like C, I think C. To part C, or otherwise, find the maximum height of the sphere above the ground and the time at which this maximum height is reached. So what we've just done now, we just like completed the square, and we know from like the studying the graphs in our previous session that a maximum can be found using this form. And for example, if we have like t minus p squared plus q, then the maximum or the minimum, it depends on like whether the graph the parabola has a maximum or a minimum, is p q. Okay, this is the turning point. Okay, so in our case, the turning point is the maximum. So if we would see in real life, it will go up, up, and then like at some point it's gonna reach the maximum height, and then it's gonna hit the ground. So that maximum height reached is from like the completed square form. It's then the maximum height is 23.275 meter. That is reached at time 1.5 seconds after sphere is thrown. So like looking at it like from a coordinate wise view, here the completed square 3 over 2, 23.275. This one represents the height, okay, and this one represents the time in seconds. And I hope that makes sense. And this marks the end of our session, but in the next few days we'll be doing more of these. So I think I have 5 more exercises like this in the exercise set. So yeah, check them out when they come out, and I shall see you in the next session. Bye.